Everybody. Today we're going to see how to use factoring to solve some problems. The past couple of classes we learned 4 methods of factoring. So we saw how to factor using GCF, which is what we try first. Then after GCF, you may try grouping, or trinomial factoring. If not, we try binomial factoring. But always try the GCF first. Now we're going to see how to use factoring to solve some quadratic equations. So should we solve quadratic? Quadratic equations are basically equations with second degree. That's what it means. So quadratic just basically means second degree. So previously we solved the equations with first degree, but this is second degree. And we call those second degree equations. So second degree equations actually define them more specifically. So it's an equation that has a power 2. The degree or the highest power in a quadratic equation is second degree. And the standard form of these equations is basically a trinomial of second degree. It's basically a trinomial, and we add an equal sign to it to make it an equation. So quadratic, this has to be 2, okay? It's second degree. And it could be a trinomial here. It could also be a binomial. So we're going to see how to solve, for example, x to the second plus 7x plus 12, as well as some binomial, such as this, for example, or some regular binomial, like maybe this. Okay, so all these are second degree equations. So we're going to solve them by factoring, specifically by factoring. There are other methods we use to solve quadratic equations. There's three other methods, but today we're only going to talk about factoring. We're going to learn the other 3 methods sometime in the future. So we'll see how factoring can make solving something like this, or even third degree. You can even solve something like this using factoring. Okay, can actually solve even third degree, not just second degree. This is a third degree equation. And for a cubic equation, we're going to see that we can easily solve this and find the value of x, or the values of x, using factoring. So that's basically how the equations or quadratic equations look like. This is again what we call the standard form. Okay, so before we solve these, let's talk about something called the zero product property, because along with factoring, we use this property to solve quadratic equations or even higher degree equations. So the zero product property. So what this means is when you multiply two things or more, AB or ABC, whatever, and the product is 0. So what does that mean about the values of A and B? If you times two things, two numbers or two expressions, A times B is 0, what does that mean about A and B in terms of their values?
Either A equals 0 or B equals 0.
Exactly. So at least one of them has to be 0. So when you times two things and you get 0, that's why it's called the zero product property. Make sure you have 0 here. So either A equals 0 or B equals 0. or both. They could be both 0 because 0 times 0 is 0. Even if we have even if you have more terms, more factors, a, b, c, so at least one of them has to be 0. If one of them is 0, then everything else turns into 0 because 0 times anything would be 0. So a times b equals 0. So either a or b or both. If we apply these two equations, if we take an example, take for some x plus 2, multiply x minus 1 is 0. So this is in this form basically. So that you can consider the first expression of the first parentheses as a, the second one as b. So we have some a multiplied on b equals 0, which means, as we said here, it's either a equals 0, the first factor, or the second factor, x minus 1, is 0. So once we do this, once we split this, basically, we split the equation. This is a quadratic equation, by the way, it's second degree, because if you times these, x times x would be x to the second. So that's a quadratic equation, even though you don't see the second power, but it is actually. So you split this into two smaller equations. Now these are just first degree. We have two first degree equations, which we know how to solve. We solved this previously. So we simply subtract 2 here to solve for x. X would be -2. Or here, we add 1, we add 1. So x is 1. So basically, we just solved this second degree equation. So in the solutions, we have two solutions, x -2 and x 1. You can check it. You can check your solutions. Basically, if you plug -2 here, this will turn into 0. If you replace x with -2, would be -2 plus 2, and x, and also -2 minus 1. Is it equal to 0? Yes, it would be equal to 0 because this is 0, and 0 times -3 is 0. That's 0 equals 0. Same thing if you plug 1 here. If you plug 1, it would be 0 times whatever you get from the other one. If you plug 0, it would be, or 1, would be 1 plus 2. And if you put also 1 here, would be 1 minus 1. We say is that equal to 0. Yes, so as long as one factor is 0, 0 times anything will be 0. So if 0 times 3 is equal to 0, yes, it is. So you have two solutions here. We can write them in set notation like this. Just like we did before with the function, set the name of the set or solution or whatever solution set, colon, curly braces, and you list your solutions from the lowest to the highest. Okay, that's how you write the solutions. That's how actually, homework, I think that's how you put them on the website.
So, Professor, excuse me. So you have two solutions, x -3 and x1, right?
Correct. Yeah.
And both is correct. Okay, thank you.
That's right. So we checked both of them and they both work. And we can write them together in set notation like this. So that's the solution after we check it. So we confirm that it works. Quadratic equations will have two solutions or less because of second degree. So expect two solutions, sometimes one or sometimes none. It is possible not to have a solution here. For third degree equations, you could have up to 3 solutions. Because of third degree, you may have 3 solutions or less, but maximum number of solutions you could have is 3. So that's basically how the zero product property works. We're going to refer to it as ZPP for zero product property. So whenever you have a product of at least 2 factors, 2 or more, A, B, C, D, whatever, if one of them is 0, so everything else turns into 0. That's what the product, the zero product property means. And it has to be a 0 here. It can't be just a number. Otherwise, it wouldn't be called the zero product property. So it's called that way because there's a 0 here. So if something times something is 0, at least one of these two has to be 0, either A or B, or even both. Possible for both to be to be equal to 0. So now let's see how to solve these. Let's see how to solve these equations and some other ones also. So let's start with maybe that one, next to second. So now we're going to do the actual solving by factoring. So solving by factoring, so it means, so if you look at the equation here, x is second plus 7x plus 12. So it's not a product yet. So we can't apply this property yet. It has to be in the form of not addition, but in form of multiplication, a times b, something like this. So how can we turn this into a multiplication like this, into some a times b? What do we need to do? Everybody, how do we turn this into this form of product of terms or parentheses like this?
So, okay, guys.
Factoring.
Right, factoring, right? So it says
Yeah.
solve by factoring. It's a trinomial, so always, again, follow all the methods of factoring you use as many or factor as much as you can. So always start with GCF first, if not trinomial, binomial. Do you have a GCF here? Is there a GCF in that trinomial on the left? Do we have a common factor? Everybody, is there a common factor here? Common factor, do you see one?
No.
There is no common factor here, right? So after that, what can we try to factor? Since we don't have a GCF, which one of these is more appropriate to try in this expression? Which method of factoring? That would be everybody, how do you factor? How do you factor this expression on the left? From what we learned previously.
Make the 7x like 6x plus 1 plus x.
Trinomial factoring.
Binomial factoring. Okay. All right. So what exactly do we do, or how do we factor this using trinomial factoring?
So it'd be 3 and 4, I guess.
So we need two numbers that multiply to 12.
Yeah. So
And-
we'll multiply 4 and 3, it's 12, it's a C.
Okay.
And we subtract, right?
That's
4
right.
and
So
3, that's 7, it's B. So it's x plus 3, x plus 4.
that's right. So since we don't have a GCF, it's a trinomial. We attempt trinomial factoring, which work when you have 1 here. Make sure you have nothing here means an invisible one. If you have 1 and degree 2, we can immediately start parentheses, 2 sets of parentheses. Then we start each parenthesis, or each set of parentheses with x. Then we'll look for 2 numbers that multiply to 12, C, and add up to B, this number. So the numbers are 3 and 4, both positive. That's because positive 3 times positive 4 is 12. And if we add them, we get positive 7. That's what we're talking about in the previous lecture, factoring trinomials and binomials, special factoring. And now, as you can see, we have it in this form of a times b. So we have the form a times b. That means either a equals 0 or this equals 0. So first factored it, and now we can write 2 equations out of it. So 2 separate equations, first degree. So if you subtract 3 from both sides, here we subtract 4 to solve, x is negative 4. Okay, so that's basically, we just solved it. So that's how easy to solve quadratic equations using factoring. So not something else. There are other methods. There is another formula. There's other ways to solve this, but today we're specifically using factoring to solve. So first, if we put this into 3 steps, first make sure your equation is in standard form, which is basically this. So standard form is when you have all the terms on one side and 0 on the other. So before you apply the 0 product property, make sure you have 0 here before you can apply this. So once you have 0 here by itself, all the terms here, then you factor. So the second step is to factor. And once you factor, so standard form factor, the last thing is to use the 0 product property, which is basically splitting this into smaller equations, as you can see. 2 smaller first degree equations and solve each one of them. So that's the process of solving by factoring. We're going to be using this over and over again for all the previous equations we saw. So that's basically a trinomial. We can apply this even to some other, binomials like this, just a regular binomial. We have to do second. Minus 12x equals 0. So the first thing, again, make sure all the terms are on one side, like this. What is the next thing we do here after the standard form? Everybody, so after the standard
But we're
form.
moving, please. I didn't get where the exponent goes.
Which exponent?
1x exponent 2 here in the third example.
So we factored this. So this we turned it into this. So this is what we call trinomial factoring. That's what we did last time, previous class.
So we get rid of the exponent, or I didn't get
right.
that.
So we turned this into two sets of parentheses. So because we have second degree here,
yeah,
we can do 2 parentheses, start each one with x, because if you times them, x times x will be x to the second.
Exponent 2.
Right? And then we found 2 numbers that multiply to 12, and same numbers add up to 3, multiply to 12. So 3 and 4, and when add them, they add up to 7. Now 6 and 2, 6 and 2, we multiply them, you get 12, but if you add them or subtract them, you can't get positive 7.
Okay, thank you.
Okay, and next one. So we have the standard form already. Again, we need to solve by factoring. So what do we do again first here, everybody? What is the first thing we do here?
We'll open the exponent,
We need to,
open parentheses.
but this one is not a trinomial. It's not like this one. It's just a binomial. Only has 2 terms.
Factor
So this,
3x. We factor 3x there.
we factor first. Always factor first using GCF. If
Yeah.
the GCF doesn't work, then you use grouping, which we saw the other day, or these 2, which we saw previous class, trinomial or binomial. These are special. Trinomial is what we just did. So the GCF here is 3 and x. Open the parentheses. Okay, so what are we getting now? What are we getting inside here?
X minus
X minus 4.
That's right. So we divide, we get x minus 12x divided by 3 would be 4. That's good. So now, do we have it in the form of a times b equals 0?
Yeah.
That's right. We have it in this form, a times b equals 0. This is a, the first factor, times what's inside the parentheses. So this is again some a times
3x.
b equals 0.
so B
That's right.
is
So
0.
so this is a, so that means either 3x equals 0 or b, which is what's inside the parentheses,
X
is
minus-
0.
So
Then we
x
solve.
equal to 0 and x equal to 4.
That's right. If you divide by 3, you get 0, or if you add 4 here, add 4, x is 4. And that's it. So this has 2 solutions. As you can see, you can plug them. You'll see if you plug 0, both will turn into 0. 0 minus 0 is 0. If you plug 4, it will also work. So always factor first, using all the methods of factoring we learned before. So we learned four methods, so all of them apply. So factor as much as possible. Once you turn the equation or the expression into product, could be AB, could be A times B times C. You turn that into equations. So that was this one. Now let's say this other binomial. This is just a regular binomial, the GCF. This is another binomial. This doesn't have a GCF, as you can see. So there's no GCF. So we're not going to use GCF. Apparently, it's not a trinomial, so we're not going to use trinomial. We can't use grouping. The only thing left is the binomial factoring we learned last time, which is the difference of two squares. How do we factor x to the second minus 25? Binomial factoring, or the difference of two squares. How do you factor this? Again, the formula was a to the second minus b to the second. What is that equal to again, everybody? Everyone, what's the formula? What is that equal to?
A minus
X
B, A
minus
plus
5,
B.
x plus 5,
This is a minus b, a
Yeah.
plus b.
a plus b.
That's right. And if we apply this to this, so the difference of two squares, x to the second, this is
X
5 to the
minus 5,
second.
X plus 5.
That's right. So the difference of two squares, x minus 5, x plus 5 equals 0. Because we used this formula. This is x to the second, and this is 5 to the second. So I applied the formula. That's good, as you can see now. So this is again standard form. We factored it. What is the next thing we do? What is the next step, everybody?
X minus 5, 0 or x plus 5, 0.
That's right. So once we turn it into a product, so a times b equals 0. So that means either a, meaning this, equals 0, or x plus 5 equals 0. And we solve each one of them. Again, we can add 5, we can add 5. X is 5. Or we can subtract 5, x is minus 5. So two solutions. So most of the time, again, with the second degree equations, you will have two solutions. But you may have one solution sometimes or no solution. It is possible to have no solution. You wouldn't find any solution here. Or sometimes just one solution. For example, if it's x minus 5 times itself, x minus 5 times x minus 5, the solution would be the same, would be 5, for example, if both of these were x minus 5, x minus 5. But that's another special factoring, the difference of two squares. So we use this, again, when the GCF doesn't work. Also, we use this special method when the GCF doesn't work. So we use trinomial factoring. This is trinomial factoring, and this is binomial factoring. Let's see another one. Or before we get to this one, let's look at some other problems. Let's do another one, binomial. So let's say we have maybe 2x to the second plus or minus 32. Or just 18, not just 18 equals 0. Same as here, it's a binomial. So what do we try first again? What do we do first to factor? Anybody? What's the first thing you try to factor?
X.
We firstly factor the 2.
Factor the 2. Okay.
Raise 2 parentheses.
So
What's
Always
X?
find, that's right. Always find the GCF first. Always see if there's a common
Yeah.
factor before you use this and before you use this. These are special. We use them after the fact that the GCF doesn't work. So 2 is common here. That's good. We're going to put it outside. X to the second minus
9.
divided by 2, 9. That's right. Equals 0. Are we done factoring, or can we factor more?
No, you got to factor again.
That's right. So we need to factor this. It looks like this, like this. So another special factoring. So 2. This will be
X minus 3, X plus 3.
that's right. So x plus 3. Good. So now we factor it completely. So you may have to factor more than once. So we did GCF here first. Then we did binomial factoring. And we have factored this completely. Now we can turn it into, we can use the zero product property. So it looks like we have 3 factors here, not just 2, not just A and B. We have 3 of them. We have A, B, and C. This is a constant. This is a number. It doesn't have X. So we don't need to turn this into an equation. 2 is just 2. It will not be 0. This is what can turn into 0, and this would can turn into 0. This can turn into 0 when X is 3. If X is 3, this will be 0. And here, if X is -3, this turns it into 0. So the 2 is a constant. It doesn't have a variable, it doesn't have X. So just ignore it. We're only going to turn the ones, the factors with X, into equations. So we say X minus 3, X plus 3 equals 0. And we basically add 3 to both sides. So X is 3. We subtract. So X is minus 3. Okay, so as you can see here, we had to factor twice, not just once. So always factor completely until you see all the factors here. If you stop here, it's still not clear. So you got to turn this into as many factors as possible. And then any factor that has X can be turned into an equation. This one, that one. This one does not turn into an equation again because it does not have X. Now let's look at the other one, 3rd degree. So this is not a quadratic equation. It's not quadratic like this one, but it says 3rd degree, but same steps basically apply to solve this y factoring. So let's take that one. So we expect 3 solutions or less for that equation. So x to the 3rd plus x to the 2nd minus x minus 6x equals 0. So again, same process, factor first. Make sure it's in standard form first, which means all the terms are on one side. Make sure you have 0 here before you factor or before you use the zero product property. Okay, so this is standard form already. What do we do next?
We factor X.
We factor, that's right, factor. And to factor, it looks like we have a common factor, which is the x1. So the first thing you do before you use any other method, use the GCF, factor anything out, anything that's common, and that's the GCF. That's right, we're going to divide all of these, divide them by the GCF. So x to the 2nd, basically just going to reduce the power by 1. So x3, then we have x1 minus 6x divided by x would be just 6. Can we factor this trinomial more? You think about the same way we used here, the trinomial factoring. First of all, we have 1 here and 2. We have 1, invisible 1. We have 2, that means we can open 2 parentheses. Only if you have 1 here and 2. If you have a different number here, you can't do this right away, but it's going to be something else. So x and x. Okay, so what else? We need 2 numbers that multiply 2. To what? And add up to what?
2 and 3, minus 3 and 2.
Minus 3. Okay, let's try minus 3 and positive 2. They add up to -6, but they don't add up to positive 1. So we have an invisible 1 here. So what do we do? Negative.
Check.
We'll switch the sign. So it's going to be a positive rather, positive 3 and a minus 2. That way, when we combine them, we get a positive 1 here. It's still going to be a negative here. So this would be positive 3 and a minus 2. Okay, let's check again. So if you times these numbers, they should multiply to this number, -6. If we multiply them, if we combine them, +2 minus 3 is in fact +1. So that's the right factoring. So standard form, then we factored completely. What is the next step after factoring? Like every other previous problem. So what do we do now after factoring completely the equation?
Put 0, x plus 3, 0, x minus.
That's right. So that's when we use the zero product property. Zero product after you factor. So in this case, you not only have a times b, you actually have 3 factors. You have a times b times c. It's kind of like this, but with an extra factor. So if a times b times c is 0, that means either a is 0 or b is 0 or c is 0. So at least one of them. Could be all of them, could be 0, or maybe 2 of them, but at least one of them. So either a, b, or all of them are 0. So now we have 3 factors because of the third degree equation. We have 3 factors here. So we have a times b times c. So that means either x, that's the first factor, is 0, or second factor, x plus 3 is 0, because this can be turned into a 0. If x is 0, the whole thing will be 0. For this one, if x is -3, that turns into 0. And for this one, if x is 2, this will turn into 0, and 0 times everything else will become 0. X minus 2. Okay, so with third degree, again, we expect 3 solutions or less. In this case, so this one is already solved. So x equals 0, or x equals, if you move 3 to the other side, it will be -3. Or finally, x equals, in this one, is 2, right? If you add 2 to both sides, or you move -2 to the other side. So as you can see, we have 3 solutions here. Now we can put all these solutions together in a solution set. And we always arrange them, okay? So arrange them from the lowest to the highest, just like we did with the set notation when we talked about functions. So -3, you have 0, and 2. So these are the 3 solutions, and feel free to check them. At least you can see that if you plug 0, the whole thing turns into 0. Each one of these will become 0. The whole thing will be 0 equals 0. Same thing with the other ones. You can check them and see that they work. So we have 3 solutions. But even if you have a third degree, equation, it still works the same way. So remember these 3 steps. When you factor, when you solve by factoring, always use these 3 steps: standard form, factor, and then the zero product property. Again, we have other methods of factoring. We're going to use those in the future, but for now, stick to these, not some other method. So you got to use these steps until we learn how to solve using other methods. Okay, so every time you will notice that we use the same, basically, steps. Okay, any questions, everybody, about any of these problems? Everyone, are you okay about this? Any questions?
Yep.
Okay, everybody else, please let me know if you have any questions. This is very simple. Again,
Professor, that's clear.
So as I told you before, factoring is very useful. This is one of the topics where it's useful. As you can see, it makes solving something like this very simple. Once we factor, we turn it into some small, easy to solve equations, first degree equations, and we get all your solutions. Thanks to factoring. Let me give you another example, a little bit different than so sometimes you may have something like this. So you have 9x and minus 20. So, so what do you think we do first here to solve this quadratic equation? What is the very first step?
You add 20 on the left side.
Say it again. What do you do with 20?
You get rid of 20 on the right side, so you add 20 on the left side. On both sides. I mean, add 20 on both sides.
That's right. So this has to be in standard form, meaning all the terms, all the factors need to be on one side. So it's not in standard form yet. We need to have 0 on one side. So we need to get rid of this. Whatever is here needs to be moved to the other side. So we're going to move this over, or you can add it to cancel it. So we're going to move negative 20 over. What happens to negative 20 if it moves over?
It will be positive.
Comes, that's right, positive 20, and it will be left with 0 here. But if you have other terms, move them over here also, then simplify this, combine any like terms you may have. There's no like terms here. So now we have standard form. Okay, what else after the standard form, according to the steps here? What do we do next?
Trinomial factoring. We can try trinomial factoring.
That's right, factor. So the next step is factor. Apparently there's no GCF. Well, we can use trinomial factoring. Again, it works if you have an invisible 1 here and 2. You can immediately start these parentheses. If not, you use another method, maybe grouping, maybe GCF or something else. And what numbers do we need now inside the parentheses to complete this factoring? Numbers are multiplied to
-5 minus 4.
That's right. Two numbers are multiplied to positive 20 and add up to -9 are -5 and -4. And if you check them, you see they multiply to positive 20 and also they add up to -9. So, and the last thing to try here, what is it? Or to do after factoring?
0
Zero product property, that's right.
separate.
Or
How do you call it? 0
zero product property.
property. Okay.
Okay, zero product property.
Oh yeah, I see.
Okay, so now we have, once you factor completely, you end up with a multiplication. So each one of these turns into a separate equation. So x minus 5 equals 0, or x minus 4 equals 0. That means x is 5 or x is 4. And that's it. So we have two solutions because it's second degree. But again, sometimes you may have only one solution. If you end up with the same factor, for example, x minus 5 here, and also x minus 5, you may have the same solution in both, which is basically one solution. So always make sure, again, all your terms are on one side. Make sure you have 0 here. So if you have some other terms, you move all of them here, change the sign. You may have to simplify or combine any like terms before factoring. Once you factor, you apply the 0 product property. Basically, you split the equation. Each factor, you write by itself. Each factor with x. Each factor with x, you write by itself. If it has x. If it has a number, for example, if this was 3, then you wouldn't need an equation. 3 is just 3, it can't be 0. It's a constant. We wouldn't have this part, we would only have these two equations. But since it's another factor, this by itself times this, and it has x, so it turns into an equation by itself, and that equation turns into a solution. And basically that's what we do every time. That's the same process. So remember, when it says by factoring, you need to use factoring. You need to use these 3 steps. If it says by other methods, which like I said, we have 3 of them, we're going to see those in the future, then you use other methods. But for now, we only use in factoring to solve. We're not using any other method. Okay, any questions, everybody, before we move on to another example? Everybody, please let me know if you have any other questions. If not, do another problem, a little bit different. So let's see. Let's maybe look at another problem. Probably something like this. And another number here, maybe -20. So think about the steps of solving. What can we do here first? Can we apply the zero product property now? Can we write this by itself and then write this by itself equals 0? Everybody, do we or can we use the zero product property right away?
We could do. We can move -20.
We need,
Yes,
that's
that's
right.
right.
We need to have,
To add -20
that's
on
right. So
both
we need to
sides.
have, exactly. So we need to have 0 here. We can't
Yeah.
have a number here. So before we apply the zero product property, it has to be a 0 on this side.
Then we
Um,
multiply with parentheses and then we factor, including the 20.
That's right. That's right. So that's what we're gonna do. Let me just make sure the signs are good so we can simplify that. So basically, well, before we can move this over, we need to multiply. We need to distribute this. So because we don't have 0 here, before moving this over, let's first distribute this. Then we can move this over to combine it with the constant with the c, with the number. So to do that, so basically we will distribute first. So it's going to be x to the second and minus 4x or plus 4x minus 3x, then minus 12 equals -12. So distribute, let's combine the like terms here. So x to the second, then we combine these two here. So it's going to be 1x and minus 12 equals -20. Now we can move this over so we can combine it with this number. Basically, you can just add 20 here and add 20, or simply change the sign. So it can be x to the second plus 1x minus 12 plus 20. So again, move this over. Equals 0. And now we can combine it. So after distributed, we can combine this with this. That's why we didn't move it first. Now we can combine those two. Plus 1x minus 12, no, not minus 12, but if we combine these two, what do we get? So positive 8, right? -12 plus 20 is positive 8. So this is just to make it in standard form. Now the equation is in standard form. All we need to do now is basically, maybe I should have put a different number. I should have put probably, put a different number, probably -6 or positive 6. So we can factor easily here. Let me change this to, -6. That's right, I'm going to change this to -6. So we can have an easy factoring. So we distributed everything, we combined, then we move. Now we can move the number here. So we can have 0 on this side. So it'll be positive 1x minus 12 plus 6 equals 0. Combine the like terms to simplify. So it's going to be x to the second plus 1x minus 6 equals 0. So all this just to write it in standard form. Because it's not initially, as you can see, it's not in standard form. It's not as convenient as this very first example we did here. So initially everything was good. It's already factored and we have 0 here. But if you don't have 0 here, and it was quickly, we solved it quickly simply by turning this into 2 equations. But if this wasn't 0, if it was, for example, 2, you wouldn't be able to do this right away. You would have to multiply all this first, move the 2 over, combine like terms, factor, and then use this. So it's called the zero product property for a reason, because you need to have 0 here. If you don't have 0, you gotta move whatever you have here to the other side. That's what we did here. So we had to, before moving this, we had to multiply these so we can have the -6 move and combine with this. We can't combine it with x's because they're not like terms. Finally, we have the standard form. Okay, so what do we do after that? Once we have the standard form, if you look over here, what do we do now? Everybody? Same steps, same 3 steps we've been doing the whole time. Once we have the standard form, what we do next?
Factoring.
That's right. Again, just factor. Because again, it's about solving by factoring. So once you have the standard form, factor, there's no GCF. So what do we do to factor this? Everybody, how do you factor this trinomial?
-3 and 2. So x in the second.
That's right. So again, we can use trinomial factoring because we have invisible 1 and 2. You
3x.
can go ahead and do 2 sets of parentheses, start each one with
3x
x.
minus 2. Yeah.
So the numbers are
+3 and -2. Right?
That's right. That's right. So they multiply to -6, add up to 1. And then you apply the zero product property. So again, A times B is 0. That means A is 0. Or B is 0. B meaning x minus 2. And the solutions are x -3 or x2. Okay, so that's basically what you do if you have something like this. Pretty simple. Just remember to have everything on one side. Sometimes you can just move something right away. Or if you have it like this, you have to break this up first. Break it up first. So we can, when we move the -6, we combine it with the number, the C or the constant. So standard form, factor, zero product property. These are your steps. Again, every time we repeat the same thing. So it's all about factoring basically. So as you can see, 80% of it or 90% is just factoring. So review factoring if you have issues with it, but it's very important. We're going to be using it for more other topics, at least 3, maybe 2 or 3 topics more. Make sure you understand it. So we did 4 of them. First one class we covered GCF and grouping. In the other class, the previous class, I believe we covered trinomial and binomial. So make sure you understand all those methods very well, because that makes all this easy. So it's all about factoring basically, and then solving. Okay,
Professor,
any questions? Mm-hmm.
Yeah, I have a question about last 2, where we have something on the right side, let's say. When we have 2 solutions, we have to check it to put in that step where it has standard form?
I'm not sure I get your question. Can you explain
Okay,
it?
if we have something about last equations, we have something on the right side, like -6, okay. And then we have two solutions. How we can check if it's correct? We have to put these numbers in a
Yeah,
standard
just no, that's it. Just plug it in here.
here.
For example, you can plug, let's say, you just plug it right away. So plug, let's say, either one actually. Let's plug this one. Let's plug 2. Just check one of them. X2.
Actually, we can plug it anywhere, right?
In the original one. So plug it in the very first equation. So let's plug 2 here and here and check it. So it's going to be 2 minus 3 and 2 plus 4. And we're going to see if it's equal to -6. This is -1. This is 6. Is it equal to -6? Yes, -1 times 6 is -6. And -6. You don't have to put it in the standard form. You can just check it in the very first equation here.
Okay.
All right. Any other questions, everybody, before I give you some practice? Okay, so let me make up some problems. Okay, so just something similar to what we've been doing. So maybe x minus 7, for example. X plus 5. So solve for x. Of course, by factoring, not by doing something else. This one and maybe 2 plus. Okay, got that one. And what else? Okay, and then maybe this one, x to second. So 2x to second plus 10. Plus 12. Okay, this one is a third, I mean, should be 3. This one is third degree equation, as you can see, and probably one more. Let's see, maybe just a second. All right, so that's your practice. So all of these are pretty simple. Each one should take you maybe a minute. I mean, this one take you seconds. Yeah, you can probably do this in a minute or so each. Some may take you a couple of minutes. Maybe these last two actually take you a couple of minutes each, but all the other ones are pretty quick, pretty simple. All right, so I'll give you a few minutes to do this, about 10 minutes or 12 minutes. You may take a short break if you wish before that. So work on this, and when we come back, we'll go over this together first. Okay, so I'll see you in a few minutes.
Professor?
Everybody, you done?
Yes.
Yes, we're done.
Everybody else?
Yeah, done.
Yeah. Oh, let's go over these together. The first one here, what are the solutions?
7, -5.
That's right. So here, x equals 7, or x equals -5. It's already factored. So if you make two equations, x would be 7, or in this one, x would be -5. Basically, for this to be 0, x has to be 7, and so on. What do we do first in this second equation? Everybody?
We make it in the standard form.
Standard form first, that's right. Need to move this over, so it's going to be x to the second plus 6x plus 8 equals 0. All right, after standard form, we need to,
Factoring.
that's right, and factor it first. So it will be x, what numbers here do we need?
2
To
and 4.
multiply to 8 and out of 6, that's right, 2 and 4. When you find your solutions, that means x is -2, and here x is -4. Basically, make two equations out of this and solve each one. As you can see, that's going to be pretty simple. Next one here, we have a binomial two terms. What's the first thing we do here, everybody? Everyone, what do we do first to solve this second degree equation?
GCF for x.
GCF, that's right, always factor first, and we have a GCF, which is 4x. Then divide 4x to the second by 4x is x minus 12x by 4x is 5. So now we have it in factorial form. What happens next? We have this in standard.
0. How it goes.
So we're going to do two equations.
Property.
That's right. So a times b is 0. So that means either this equals 0, 4x equals 0, or the other factor equals 0. And solve each one. So x is 0 here, or x is 5. If you move the -5, you add 5. So we have two solutions. Next one, another simple one here. X to the second minus 36 equals 0. What is the first thing we do here, everybody?
Follow the formula.
That's right, the difference of two squares. So x to the second minus 36 turns into this would be x. What do we get here, everybody? How do you factor x to the second minus 36?
-6 plus 6.
X minus 6 is x plus 6. Then you solve each one. So that means x is 6 here. And for this one, x equals -6. So again, you see how factoring can make things easy here and pretty simple. The next one here is a third degree equation. It's a third degree equation, but again, the steps are the same. They're all here. So what do you do first? What do we do first to solve this?
Put it in standard form.
What is the rest of the class? What am I talking to only one or two students?
You factor the x.
Common.
Everybody else. I know I'm talking to 2 or 3 people, but what is everybody else? You guys even here or not? Were you just sleeping and waiting for the attendance? I don't understand what's going on here in this class. Everybody's expected to practice, to participate and answer questions. As you know, it is part of your grade, you know. Everything matters. Everything you do in this class matters.
I got to x parentheses x exponent 2 plus 5x plus 6 equals 0.
That's right. So first we need to factor using the GCF. So we have 2x as a common factor. So 2x is the GCF. You open the parentheses and then we divide
exponent 2 x squared plus 10 plus 5x plus
Okay,
6.
plus 6. So that's the GCF. We divide all of these by 2x. We get this. That's the first thing. What else?
Okay, so I got x equals 0, like x equals 0, and I do like what is it?
First,
Factoring.
can we
give me-
factor more?
Yeah.
So you can factor x squared plus 5x plus 6 is gonna give you
That's right. So we're gonna factor more, factor
x
completely.
plus 3,
3 plus 2. We express the
x plus 3,
5x like a 3.
and x plus 2.
That's right. So factor GCF, factor again if possible, completely. Now we end up with 3 factors because it's a third degree. We have 3
Yeah.
factors.
So x equals 0 is gonna be x
so we're
equals 0.
That's right. We're going to turn each one of these into an equation because they all have x in them. So it's basically a times b times c is 0. So it's either 2x equals 0 or the other factor.
X equals 0.
That's right. Or x plus 2 equals 0. So each one needs to be turned into an equation because they all have x. You solve each one of these. So x is 0 or x is, if you move the 3 over, negative 3 or
negative 2.
That's right. The last one, if you move x to the other side, x is negative. So we have 3 solutions. Again, you can divide them in solution set from the lowest to the highest. So do negative 3, negative 2, and 0. So even if you have a third degree, again, always apply same steps as solving quadratic. The last one here, as you can see, we have something times something equals negative 14. So what do we need to do first here?
First we distribute.
Weird.
That's right. So we need to have 0 here. But before we can move this over, let's distribute this. So we can move this over, just like we did with this problem, exact same steps. So distribution will be x to the second minus 4x plus 5x minus 20. That's right. You can even move this right now. Positive
Plus
14. That's right, equals 0. So we move this. Now let's combine like terms. So what do we get?
1x.
That's right, plus 1x and
minus 6.
Minus 6.
minus 6 equals 0. So now we have it in standard form. So this is the standard form. It needs 0 here and all on the other side. And now we just need, what we do next with this side?
X minus 2.
So we're going to factor it. That's right, x plus 2x minus 2, factor it. There's no GCF, we use trinomial. Finally, x plus 3 equals 0, or x minus 2 equals 0, which means x is minus 3, or x is, we move 2 to the other side, is 2. Okay, so it's probably the longest you can get. So when you have a situation like this, it's not that complex. This is what you do. Again, just distribute, move the number, factor, and solve. And that's basically how easy it is to solve by factoring. All this made easy because of factoring. So make sure you know your factoring first so you can apply it here. So I have a couple of lectures on factoring. Make sure you review those if you still have issues with factoring. Any questions, everybody?
No.
Okay, everybody else, any questions about any of this, please let me know.